want high voltages, strong electromagnetic field, high temperature, high pressure, that works. Now this is one major advantage. The other advantage already proven and used in telecom is the ability to make sensors that are self-identifying. Okay, you are familiar with electrical sensors. Each one has its own cable. Now, if you have 30 of them, you don't know which one goes to where. We have a unique technology. The fiber grating is a color sensitive mirror. So you can take the data and reflect on where the location originally was. So this becomes a very intelligent solution base. Now, so the technology is ideal for remote and distributed sensing. Later on in the presentation, I will give you a little bit of hints as to where we are going. What you see is QPS continuing pushing the envelope on this fiber grating. Today, our solution mainly involves a star network. That means it's still one cable, one sensor, but we want to fulfill multi-function per sensor. That's the reason why we wanted to monitor vibration, amplitude, as well as hotspots in that vicinity. So we have three major product lines. HPS stands for hydropower system. This is mainly for hydro. And then we also develop a OEM product line. This is a product line for guys like Siemens and other companies that want to market it under their own brand. Okay, so that's now the one that I want you to know a little bit more about is this TG guard, turbine generator guard. Okay, now it can help you diagnose through vibration and hotspot measurement. Okay, and it's adapted to all kinds of generators. It can be coal-fired, can be gas-fired, can be even nuclear. Now, but I understand that nuclear have other concerns. They are very worried about radiation, and we figured that we have to make a little bit more modification in our technology in order to do that, because I was in Ontario Hydro, and they showed me how the stainless steel fixture gets actually distorted over time. Stainless steel and through radiation. So, and their dilemma is this. They bought some ultrasound sensors, and the ultrasound sensors could not live very long when they try to install it to measure vibration. So this problem continues, and we will address these needs as time goes by. So just give you an idea, the white color package. Okay, the packaging is needed. You said, well, fiber grating is a hair. Why did you show me something so big? Okay, well, it's very dirty. Inside the generator, there is oil, there is dust, and then the sensor is mounted on a platform. And so if you allow these contaminants to deposit in it, its characteristic will change. So if you want to monitor vibration over time, you got to make sure this thing is linear and repeatable. That means it should not change its character. So the white color differentiate this in the various solutions. This is for low temperature hydro. Then later on, I'll show you the different package, which is for the coal-fired and gas. Now, application, we install a few of our solution in India. These are power plant owned by the Tata Group. And in this case, you see our sensor installed in the radial position in the end cap. And that on the tangential on the end cap. Yeah. So these seems to be the two main concern directions. Like they worry about vibration in this manner on the side and then like this, okay, like a fishtail. Now, so far, any question? No? Okay. So now we walk right into what causes your generator to fail. Now first, to start with, there is always a electromagnetic induced vibration. It's the interaction between the rotor and the stator. So as a matter of fact, every time the rotor turns once, in a two-pole design, so you will have a vibration frequency generated which is double that of line frequency. And this is very clear. You don't have to worry about noise. This application is very simple. You just look for that target signal. Now, this target signal actually is inhibited by tightness. You have stator bar wedges and other structure. If they are mounted very tightly, the vibration it cannot move. Okay, so if you look at the detailed webinar, I will actually show you the example of the simulated wedge together with the signal generated from various situations, looseness, tightness. How do we differentiate? Now, when this vibration is permitted to grow, then it got so severe. What I mean is, I consider 10 micron to be acceptable. Now, if that's 10 micron vibration grow beyond 50 to 100, we got a problem. What happened is this: with this amplitude, the neighboring structure will start to rot, and then this caused the insulating layer to deteriorate. And I show you some evidence of that when you look at it. When you open up and you see them, the symptom of that. Now, then they lead to partial discharge. It's arcing. When the insulation layer is not working well, then you have localized discharges. We call that partial discharge. And then eventually they grow in number, clusters of it, and eventually you have a major catastrophe like shorted turn, short circuit to ground, and fire. Okay, the very first one we installed in India was caused by a fire, and it burned almost 1/4 of all the windings. They were shut down for 3-4 months, and they swear to God they don't want to see it happen again, and immediately call us and we install. So they are happy right after. So we can help you prevent similar catastrophe. Now, one thing though. You said, well, looseness. Well, I can visually inspect that, yes, but you need to open up the whole thing, let a guy to go in. The rotor has to come out, and this is not a simple affair. You know, maybe you only want to do that once every 8 years. Okay. So even if you open it, think about how many windings and how many slots there are, and you need a trained eye to do that. Okay, so you see these ripple springs at different wedges, and very difficult indeed. Now, in this case, they were able to find it in a 240 megawatt, and X, the places where they think is loose. But wedges are not the only one. Well, you could have loose ties on surge rings and things, and this is Elstone. 90 megawatts. Now, here it is. If you allow the vibration amplitude to grow in time and continue, you begin to see white powder. Okay? The white powder is actually evidence of the rubbing. These are the resin residues. Okay? So if you see the white powder, you should be concerned. So, when the white powder exists, then there are onsets of partial discharge. And I explained before, these are arcing events that happen in clusters. Okay, what TG-Guard will do is to capture the onset, the very onset of partial discharge. Very early, before white powder comes in, you already have